Hello and welcome to Electronic Solutions. If you are new to the channel, then please subscribe the channel and hit the bell icon for the latest notifications. In this video, we'll discuss about the different types of architectures. So first, let us see what is the meaning of computer architecture. The computer architecture is nothing but it is a set of rules and methods that describes the functionality, organization and implementation of computer systems. Now mainly there are two types of architectures. One is a Von-Neumann architecture and second is Harvard architecture. Now we'll see both of these architectures one by one. The first will go for Von-Neumann architecture. The Von-Neumann architecture is based on the stored program computer concept. That means it has only a single memory for their instructions as well as data. It uses a processing unit and a single separate storage structure which is called as a memory to hold the instructions and data. In this case, only one bus, that is a single bus, is available for the instructions and the data. So the instructions and data they have to be fetched in the sequential order only. In this case, the processor basically needs the two clock cycles to complete the instruction because the pipelining the instruction is not possible with this von Neumann architecture. But as only one physical memory is there and a single bus is there, it will actually give rise to a simpler design in von Neumann architecture. Now this is a block diagram for the architecture. So it has a CPU, that is a central processing unit, so which contains the control unit, arithmetic and logic unit and the registers, and there is a memory unit, physical area for memory, which contains the data memory and the program memory. But remember that the memory unit or only a single memory is present for the instructions and the data. Along with it, it has a input and the output devices. So the components inside the CPU we have already discussed in our previous video. So I will provide the link of that video in the description box. So you please go through that link. Now in this case, as I had told you that the processor needs two clock cycles to complete the instruction. So in the first clock cycle, the processor gets the instruction from memory and decodes it, and in the next clock cycle, the required data is taken from the memory, and therefore for each instruction, this cycle repeats and needs two cycles to complete one instruction. The problem or the bottleneck with this von Neumann architecture is the instructions and the data have to be fetched in the sequential order, and which will limit the operation bandwidth and the speed. So we can say that this is one of the bottleneck or disadvantage of von Neumann architecture. But in spite of this, this von Neumann architecture is used in the small computers or in the personal computers. Now we'll discuss the second architecture, which is called as an Harvard architecture. The Harvard architecture mainly based on the modern computer architecture on Harvard Mark I relay based model. Now this architecture basically uses a separate physical memory address for the instructions and for the data. Now because of this, as they are using the separate memories and the separate data bus and the address bus, the design of this architecture becomes little bit complicated. But as the separate buses are used for transferring the data and the instruction gets executed in only a single cycle. Now we'll see the block diagram. So see the difference between the von Neumann and the Harvard architecture. So here you can see that there is a separate data memory and a separate program memory, and also the buses are also separate for data as well as the program memory. And because of this structure, the processor can complete the instruction in one cycle if the appropriate pipelining strategies are implemented. Here, instructions and data can be fetched simultaneously, as there is a separate buses for instructions and data, which will increase the operational bandwidth. And therefore, this architecture basically solves the problem which is present in the von Neumann architecture. If the pipelining strategies are implemented, then in the first stage of pipeline, the instruction to be executed can be taken from the program memory, and in the second stage of pipeline, the data is taken from the data memory using the decoded instruction or address. And such type of architecture or the hardware architecture is mainly used in microcontrollers and in signal processing applications. So this is what is the major difference between the von Neumann architecture and Harvard architecture. So if you like my video, then please subscribe to my channel and share the video with your friends. Thank you guys. Thank you so much.